Welcome, everybody.
Hi, pre-calc.
We're back for another fun week of teaching and learning.
Virtually.
Like last week and next week.
The rest of the school year.
Whoop, whoop. Whoop, whoop. All right. This week, we're going to be learning about arithmetic sequences and recursive functions. Y'all ready for this?
Dun, 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 dun.
All right. So we are going to start by talking about what a sequence is. It's basically a function with the domain equaling all positive integers. That would be the natural numbers, the ones you learned to count when you were little tots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. When we have a sequence, it is the set of numbers that fulfill a pattern. So since it's a set, we use set notation, which are these lovely little braces. We also name a sequence, just like we name functions with f of x, g of x, h of x, so on. We name a sequence, but we use A, B, and C with a little subscript. So that's a little bit different. That's just to distinguish it from a function into a sequence that only uses natural numbers. So we use the n instead of an x because we're only using natural numbers. Like I said, the counting numbers that you learned when you were little tykes.
What can it be? Any counting numbers? Can I use like -1 and 0 and like
You didn't learn to count with a -1 when you were a little tyke, Miss Willis.
What about 0 though?
You didn't learn to start counting with starting at 0, Miss Marshall. So no, it's just 1, 2, 3, 4.
Okay.
Okay. Right. So, all right, the arithmetic sequences, that's a specific kind of sequence. So a sequence is any kind of pattern. An arithmetic sequence is a very specific sequence where the pattern is found by adding the same number each time. So for example, 5, 7, 9, 11. If you look at that, what are you adding every single time?
2.
You're so smart. So we are adding a 2 every time. That is called the common difference between these. We use a D to represent that. So D is the common difference. Now I left a big space right here to kind of show you the difference between a sequence and an actual function. If I plotted out 5, 7, 9 as a function like this, we would connect them. And we would go like this and connect. Every point in between the 5, 7, and 9 would represent decimals in between these that also work in an actual function. The problem with connecting them all is that you are also using decimals and fractions and negative numbers and using all those real numbers in between. So this would be a function. So I would call that f of x. A sequence is literally just using 5, 7, 9, 11. So a sequence, I'll call this A sub n, is literally just using those points.
That looks like a discrete graph.
Oh, that's a fancy word.
It looks linear with the green one though.
Yeah, so this one is a linear function. Over here we have a sequence. All right, so the formula for arithmetic sequences, we're going to write down A sub n, and you don't have to use A. Again, you can use B, you can use C, just like you can do f of x, g of x, h of x. We just typically default to an A. But the way you find the formula, even though it's linear, so it's going to follow the same kind of feel as a line, but a lot of times it's easy to find the formula for an arithmetic sequence if you use the first term in the sequence, we call that A sub 1, representing the first number in the sequence, plus the common difference times n minus 1. Now, again, this is very similar to what you would do for the equation of a line, but the problem with the equation for a line is that the equation for a line has a y-intercept, which happens when your x value equals 0. Now, like what Ms. Marshall was asking before was, can we use 0? And here we cannot use 0, which is why this isn't exactly the equation of a line. You will see, though, sometimes when we find the formula for the sequences, it's going to end up looking sort of like the equation of a line. You'll see some similarities. All right, so let me show you how this works. In the example, it says find the formula for the sequence 5, 7, 9, 11. So using the formula that we boxed in, we want to first determine your A1 value. So that's going to be the 5. I think when I asked up here, what are you adding every time? We said that was 2, and I said that's known as the common difference. So that's the D value here, that's 2. And then we write down n minus 1. So that n minus 1, what that does is it acts like you're shifting to the right one. And what that does for your number values is it shifts everything to the right one. And so numerically speaking, it's like shifting everything to the y-axis in your pattern, so that when we actually write out our equation in simplified form, you get what looks like y equals mx plus b. All right, so now when you look at this, you get a sub n equals 2n plus 3. So if you actually had a linear equation, then your y-intercept would be at positive 3. Whereas the first term in your sequence is actually at 5, because that's what the value is when n equals 1. I hope that made sense.
So I can use that to find other terms of the sequence.
Yes, just like you can if you had the equation of a line. Whenever you substitute in a value for n, you're finding another value in the sequence. So if I want to know what is the 10th term in the sequence, I would substitute in a 10 for n.
Does this have a fancy name? I feel like there's a fancy name for this kind of formula. You might have said it. I wasn't paying attention. I was on my phone. I'm sorry.
Does it have a fancy name?
Yeah, isn't it like explicit? I feel like I said.
Oh, I mentioned that later on in the notes. Yes.
Oh, okay. Sorry.
Oh,
This is an explicit formula. This is the explicit formula because it's straight up telling you exactly how to get all the other terms in the sequence. So it's being very clear, explicit, like this is how you do it.
Gotcha.
All right, so our next example is actually a word problem, and a lot of you are really smart people, and you could probably figure this out without doing a formula. Others of us would prefer to have formulas to figure some stuff out. So it says, when training, Johnny B. Good does 15 push-ups per day during week 1. During week 2, he does 20 per day. During week 3, he does 25 per day, and so on. How many push-ups per day will he do in week 500? So this kind of goes along with what Miss Willis was asking. Can we actually figure out from our formula other terms in the sequence? So this problem is actually asking you to figure out the 500th term in the sequence. Does that make sense?
Yeah.
yeah.
Because
So we got to
week
make an
1,
explicit formula.
15, week 2 is 20, and week 3 is 25. We're going to keep going, and we want to figure out what number of push-ups he's going to be doing in week 500.
And there's no way I'm going to find week 4 to week 500. Like, that's ridiculous.
That is ridiculous.
Yeah.
Some people might try to do that, but that takes a lot of time. So what we want to do is we want to write the explicit formula and then substitute in 500 for that. So we're going to do that. We're going to do a sub n equals a1 plus the common difference, which is 5 times n minus 1. So we get 15 plus 5n minus 5. And so that's going to be 10 plus 5n. So that's your formula. Okay, and then you substitute in 500 for the n. So we're going to put a 500 right here. So 10 plus 5 times 500. And then that's going to give you how many push-ups per day that Johnny B. Good is doing. And I think you are going to realize that it's a ridiculous number.
He's gonna be both
Yeah, he's going to be swole.
super swole.
2,510 push-ups.
2,510 push-ups per day.
He must be in quarantine.
And
That
has nothing else to do.
Nothing else to do. All right, example 3 says the first term of an arithmetic sequence is -3, and the 53rd term is 101. Find the common difference. So A1 is -3, and then A53 is 101. Find the common difference. There's a couple different ways you can do this. Some people treat this like, hey, this is a linear equation, and since it acts like a line, the common difference is like a slope. So some people do this like a slope problem. Other people do this like a system of equations using this formula up here. So there's different ways you can do this. If you treat this like a slope problem, you have to be really careful and know that this stuff is like your y. So I'm going to say it's like y. And this stuff over here is like your x. That's probably the easiest way to do this. And this is how, this is a method I learned actually from my students. I always used the formula before until I had really smart students that were like, why don't you just treat it like slope? And then I was like, oh yeah, you guys are smart.
Oh, they are.
So much sense.
Because all arithmetic sequences are linear.
Yes, so all arithmetic sequences are linear. You can just do slope. You can do change in y over change in x. And that's going to equal the common difference. And so y minus y over x minus x. So change in y over change in x. You do minus negative is plus. So you get 104 over 52. And get that the common difference is 2.
Learn something new every day.
Yeah, one of my students taught me that. And it's a lot quicker than doing any other method.
Yeah.
Students are smart.
So smart.
All right, so example 4 says Frederica weighs 275 pounds on the 30th day of her diet. On day 67, she weighs 130 pounds. I do not recommend this. Do not try this at home. I think she lost too much weight too fast. What was her original weight and what was her average daily weight loss? We're going to figure out what Frederica did. For her average daily weight loss, that means we're trying to find out what D equals. Now, this problem is assuming that, well, since it says average, we're figuring out a constant amount each time. So the common difference here would be the same since it's an average. Okay, so we're going to start by finding that D value, and we're going to do it the same way we did in example 3. So assuming that this is linear and that she's losing the same amount every day and that's staying constant, we're going to look at this like A30. So the 30th term is 275 and the 67th term is 130. we're going to figure out what the average daily weight loss is. So we're going to figure out that D value, and we're going to do that like a slope. So again, these would be the Y value. So that's Y, and these would be the X value. Okay, so we're going to subtract those from each other. So 130 subtract 275, and then 67 subtract 30.
Negative 145.
Oh, you did that already? You're fast.
I'm smart. I'm a student, remember?
So it's negative 145 over
Negative 37. Negative not 37.
positive 37.
Yes.
So then if we divide those, you're going to
I
get
think
a weird decimal. Right?
negative
So-
3.92.
Okay, so that's the average daily weight loss. So this is why I don't recommend this. Don't try this at home. Losing about 4 pounds a day is a really bad idea.
Wait, why is it negative?
Because
Because
she's
she's
losing.
Oh, okay.
Oh, Marshall, duh. She's on a
I'm a smart
diet.
student.
on a diet, yeah. All right, so now it's asking us what was her original weight. So we're trying to figure out what the first term in the sequence is, right? So what you can do is figure out the fact that we have our formula, right?
Oh, I think we know everything except a sub 1 in that formula. Like we can plug everything in.
Yeah, you can take either of the things that you have, a 30 equals 275 or a sub 67 equals 130. Take either one of those. Remember, those are like an X and a Y. So in this case, let's just use this first one. So if a sub 30 is 275, that's like a Y. So 275 equals A1 plus D, which is negative 3.92, and then times n minus 1. And so the n value, that's like your X, that's 30 minus 1. And then you just solve that. Okay, so I'm going to do the negative 3.92 times 29. I get negative 113.68. And now I'm going to add that to the other side. And I get that she weighed originally 388.68 pounds on the first day of her diet.
Ooh. So she was really trying to lose some weight.
Yeah. But she's doing it too fast. She needs
Way
to
fast.
try a healthier approach.
Yes. She must have been on a keto diet.
She must have been
Maybe-
starving herself or something. So
Maybe she had I don't know.
she needs to be
no.
healthy. All right. So now on to Miss Marshall.
Ooh, it's gonna be interesting. No, it's gonna be fine. No, it's gonna be interesting. Okay, so let's present my screen. You should be able to see it. Okay. All right, so let's begin. We're gonna do recursive formula. And oh wait, let me find it. Okay, here it is. Okay, so when you are doing recursive formulas, recursive always has two parts, so that's like a key. So you got to have two parts. And the first part is a starting place. So you got to figure out what a sub 1 is. So that's like step 1. And then step 2 is what is your rule. There are two ways to write rules. So we'll talk about the two ways. And yeah, so we'll talk about the two ways. And it's dealing with like these terms, next term and the now term. And then the other way is dealing with the now term and the previous. So it just depends on how you want to write it, which one makes the most sense. So let's do this first example. Okay, so it says, write the first 5 terms of the sequence. So we want the first 5. Okay, a sub 1 is the first term. Okay, so this is like the first part. And we just write it out. A sub 1 equals 2. And then this is the second part. This is literally the rule. And this rule is telling us that if we take 3 and we add it to our term that we have now, that will give us our next term. Woo! So let's see what that looks like, and then I'll show you the second way of doing this. So again, we have a sub 1 is 2, and then in order to get the next one, we're just going to take our a sub 1 and add 3, then our a sub 2 and add 3, and then our a sub 3 and add 3. Just keep on going, so on and so on. So first step is I think about what is n. So I know that I want this to be a sub 2, and so that means n equals 1. And literally when I'm plugging it into here, if n equals 1, then that means I have a sub 1 plus 1 is 2 equals 3 plus a sub 1, which is just a sub 1. And so then I literally just have to solve it. A sub 2 equals 3 plus 2, which is 5. Ooh, that's a whole lot of work on the side, but just so that you can see how it works. Okay, then I do the next one. This time I want to technically get, before I write my n, I want a sub 3. So then it's like, okay, well, what does n have to be so I can get a sub 3? And again, you're looking at it from this point right here. Well, what n has to be so you can get a sub 3 is it has to be 2. And so then you do the same thing. N equals 2, so it's a sub 3 equals 3 plus a sub 2. And you're just adding it together. 3 plus a sub 2 is 5, so now that's 8. And so a sub 3 is 8. And doing it again, n equals, because we want the first 5, so that's only 3. We need 2 more. So when n equals 3 this time, because as you see, it's just going in numerical order, that's going to be a sub 4. And so over to the side, a sub 4 equals 3 plus a sub 3. And a sub 3 was 8. So a sub 4 is 11.
Do I have to keep doing that if I notice that I notice my pattern now?
That was my question.
Absolutely not. You can see that from each one to go to from 2 to 5. What are we doing?
Adding.
Yes, adding 3. So then from 5 to 8, you're adding 3. From 8 to 11, you're adding 3. And so our last one, since we want 5 terms in all, but remember a sub 1 counted as our first term. So n sub 4 would be the same as a sub 5 equals up, just add 3. And so that's 14. Makes sense?
Yeah.
Okay, let's look at how it works in terms of a different equation. So we dealt with, to begin with, this now and next situation up here. This is one way you can do the rule. Another way you can do the rule, let's see if I can explain it right, is if you get the next and you're trying to solve the next one by plugging in the previous. So it's a different way of thinking of it, although you're using the exact same numbers. So the way this would look is a sub n equals, and then, well, if you want a sub n to be the next one instead of the current one, well, then to get the one before, you have to subtract 1. So then this would be 3 plus a sub n minus 1, or a sub n minus 1 plus 3. So it can flip-flop because remember, addition is commutative, so you can add it in the front or in the back. So it just depends on, I guess, what equation you're going to be given / what equation they ask for. If we ask for, it doesn't really matter which one you give us. But in terms of what you may be given from us, you may have the next now situation or the next previous situation. It just depends if you have a +1 or -1. +1 means that's the next, -1 means that's the previous.
Gotcha.
All right. Let's do the next one, next example. Okay, so we have our first part is A1. So that gives us our starting place. And then we need our, it gives us a second place. So not only do we have a starting place, we have a second place. So A sub 2 is 2. And then
we have to find 3 more?
Yep. Because 3 plus 2 is 5. Yep. So this is our second part. Remember all this right here is now the first part, and then our rule is the second part. Okay, so our rule, we're trying to find A sub 3, A sub 4, and A sub 5 because we want to find. My students know Miss Marshall will become Jamaican real quick. But we have to find those 3 answers. And so now we want to figure out, okay, what does n have to be? Just thinking about it. Okay, n, if I'm looking at this, I want n to equal 1 for that one. And then it would n equal 2 for that one, n equals 3 for that one, just so that you can relate the n situation, to the problem. So just over here to the side, a sub 3 would equal a sub, what is happening? A sub 3, okay, here we go, equals a sub 1 times a sub 2. All I'm doing is plugging in n equals 1. A sub 4 would equal a sub 2 times a sub 3. A sub 5 equals a sub 3 times a sub 4. And so we just literally plug those in and solve. So a sub 1 is 1 times a sub 2 is 2. So our answer is 2. Yay! Then we do the next one. A sub 2 is 2 times a sub 3, which is also 2. So the answer is 4. And then the last one, a sub 3 is 2 times a sub 4, which is 4, and that is 8. And that's how you would solve it.
This one's hard to figure out the pattern just by looking at it. So I really got to use my formula.
Absolutely. Why? Because from here to here, it's like, just add 1. Yes. Okay, so the next one will be 3. And then it's not.
But it doesn't say it's arithmetic. That's why I can't do that, because this is recursive.
Exactly. So you got to be careful with doing patterns like we did for the first example, because sometimes the pattern, you can do the pattern, but just make sure it works all the way through to at least your 5 terms that you're trying to find. And if it works, you're good. If not, you have to use the formula. All right. Gotcha. Let's do the next one. Okay, it says find the first 5 terms of this situation. So it's essentially the same exact thing. This would be a good time to pause the video and see if you can get it.
Yes.
Or you can keep on watching because I'm gonna keep on going. So this is part 1. This is part 2. All right, we're doing the same thing. We want the first 5 terms. A sub 1 is 3. A sub 2 is 3. A sub 3 is something. A sub 4 is something. And A sub 5 is something. All right, let's see if we can figure it out. Okay, doing this over here to the side. A sub, we want 3. So then that means we got to do A sub 3, which therefore n has to be 2. So this is n equals 2. This would have to be n equals 3. This would have to be n equals 4. It always goes in a numerical order, a linear numerical order or single numerical order. I don't know. So a sub 3 a sub 3 equals a sub 2 minus a sub 1. A sub 4 equals a sub 3 minus a sub 2, and a sub 5 equals a sub 4 minus a sub 3. All right, and now we just gotta plug it in, and figure it out. Okay, so without getting lost, that's why I like to write this part out over here, because I don't know, I just personally just be lost. But if you're a super smart student or not, you can write it or whatever you decide. So a sub 2 is 3, and 3 minus a sub 1. So 3 minus 3 is 0. Okay, a sub 4. A sub 3 is 0 minus a sub 2 is negative 3. And a sub 4, which is negative 3, minus a sub 3, which is 0, is another negative 3. And so those are the first 5 terms. Another way
I
that
just figured out how you got your n, because I was a little confused. So all you did was like you wanted the third term, so you set 3 equal to n plus 1 and solved for n. So that's why n is 2, because in the other ones your n's were 1. Ah, that just makes sense. That's how I know what n I'm starting with.
yes.
God.
And that's also how you know, like, that you're doing the right ends anyway to begin with.
Yeah.
Because you're right. The other ones I did start at 1, like, automatically. But this one, no,
Yeah.
you had to get the a sub 3 first. Oh, yes. Good observation, Ms. Willis. The
I was a little
answers, oh, gotcha. The answers, you can write them as a sequence in this form. And this would be the final answer. And that's it. All right, last one in this recursive section, negative 3, 0, 3, 6, 9. Okay, just want to make sure I can still see it. Oh, I guess I could have zoomed in. I'm right real like
I
tiny.
know. I should have said something.
It's okay. Okay, so this one says find an explicit rule. So we need to figure out what a sub n equals for this one. So what in the world is a sub n? Versus the other one says find a recursive rule. Remember, we need 2 parts for this. So we got to figure out what a sub 1 is. And then let's see, which way do we want to do it? Let's do it a sub n as well. We can actually do both. It doesn't really matter. You can start with the other one and then do this one, or do this one and do the other. Whichever you decide. We're gonna do both. Okay, so explicit. We need to figure out, is there a pattern to get from negative 3, 0, 0, 3, 3, 6? Do y'all see something?
I think you're adding 3, maybe.
Let's see. Okay, add 3, that's 0. Add 3, that's 3. Add 3, and that's 6. Oh my gosh! Yes, honey. Yes.
Yes.
Woo. So the way you do explicit, remember, you start with the first term. Our first term is negative 3. And then you are going to add the common difference. And so this one means that D is 3. And in parentheses, n minus 1. Because that's the formula that Ms. Fisher just taught you. And now we can clean it up so that we can have an explicit simplified rule. It doesn't say the word simplified, but you need to know you got to simplify it. Okay, so then this is negative 3 plus 3n minus 3. And so our explicit formula will be 3n minus 6. A sub n equals 3n minus 6.
That was easy.
Yes, super easy. Now we got to get this recursive formula going on. So recursive starts the same way in terms of what you start with. So we started with the negative 3. Okay, so we got to start with that. And now we need a rule. Okay, so the way that we're doing this rule is this is going to represent the next number. So that's the next number. So in other words, we need to do what? In other words, to get 9 from the previous number 6. What do we do to get, or what do we do to 3 to get the next number 6? What do we do to 0 to get the next number?
Add 3.
Add 3. So we just taking the previous one. We're going to subtract. That's the previous. Let me write the word previous. Okay, just abbreviate it. And then add 3. So that is one recursive formula. So this is one answer. Ta-da! And you don't need the next and previous underneath. I just wanted to show you that. Or you could have same thing, a sub 1 equals negative 3. And then this time, we're going to use the formula. Oh, we don't want to sync. Stop doing that. A sub n plus 1. So this time it's the next one. Well, it's the same thing. To get the next one, you're just going to add 3. So it's 3 plus a sub n, or a sub n plus 3. You could totally put it in the same order. And That's
But you
easy.
can't have you have to have both parts. I can't just write a sub n equals a sub n minus 1 plus 3. Like I have to have the starting because they got to know where you start, y'all.
Got to. So both of these, I'm put a little comma. Both of these in each individual circle has two things. You got to have two things when you do recursive. Got to. And I am done. So I'm going to stop sharing. And it is Miss Willis's turn.
All right, guys, I'm going to try to make this short and sweet. We'll see. We'll see. It's a long video. It's okay. You got nothing else to be doing right now, maybe. I don't know. All right, so here we go. You need your calculator, of course, for my part. So
You're the calculator queen.
Woo!
I downloaded the old one because it doesn't work the same for both, unfortunately. It's okay though. We're gonna do this. Arithmetic sums. You might have noticed at the beginning of the video, Fish says it a little bit different than I. Just don't say that this is arithmetic. This is not arithmetic, okay? So I say arithmetic, and that's, yeah. Anyways, arithmetic sums.
I say arithmetic.
Yeah.
Oh,
just
and
not
I say
arithmetic
too. Just not arithmetic.
No, that's a different type of math. That's an old math they used to learn back in the day. All right, so arithmetic sums. It was discovered by the mathematician Frederick Gauss when he was just 10 years old. What are you guys doing in quarantine? Are you discovering a formula? No. The formula for the sum of the arithmetic sequence is this right here. So we have Sn equals n divided by 2, parentheses a sub 1 plus a sub n. Woo! Okay, that's our sum when we're trying to add everything up like this first one. You don't want to sit there and list all 50 terms and then add it up. That's going to be taking too long. So this is the sum formula that this kid, Gauss, made. And yeah, so we're just going to jump.
He actually came up with it as a way to avoid doing busy work when his teacher gave him busy work.
He was a smart kid. He was like, this teacher doesn't know what she's doing, so I'm going to make a formula.
Pissed her off.
Y'all can relate, huh?
All right. So let's do his formula to find the sum of the first 50 terms of the sequence. So N stands for, so let's write, that's N is going to be 50 because he wants the first 50. So I'm going to plug in 50 divided by 2. And then a sub 1, just like in all of the other problems, was the first term, which is 2. Ooh, I don't know a sub 50 yet. So I'm going to have to do some work to get this first. Oh, man. All right. So we got to figure out the pattern. What's the common difference? What's the common difference, y'all? 3. So a sub 1 is 2 plus my common difference, which is 3. And then I can plug in n minus 1. Now you can clean it up, but I feel like that's doing too much work when I could just plug in 50 minus 1 is 49. So to get the 50th term, I would just be 2 plus 3 times 49. I actually need my calculator for this. So 2 plus 3 times 49.
149.
149. Thank you, Miss Marshall. So 149. So I did have to use what Fish talked about. I found my explicit formula first. So this was a sub n equals that. And then I plugged in 50. Now to get the sum though, I need to just clean up. I have everything. Everything's filled out in this formula right here. So we're just going to type that in. So 25 times 2 plus 149. So that's just times 151.
Yep.
And that's 3,000. So the sum of all 50 terms equals 3,775. Hopefully that makes sense. All right. Dancing too much over here, getting warm. All right. So Raphael makes 28,000 as a first-year teacher. Ooh, I can relate. He gets a 500 increase each year. After 30 years, how much will he be making? How much total money did he have over his career? So what do we know? What did they give us? Well, he started first year. So I guess that's my a sub 1. He started at $28,000. Then he gets a 500 increase each year. So each year they're adding 500. So that sounds like my
difference.
Yes, my common difference. Now we want to know how much he's going to make after 30 years. So I'm going to make my explicit. So A sub n equals 28,000 plus 500. And I could put n minus 1, but I already know what I want. I want 30. 30 is my n. So 30 minus 1 is just going to be 29. So if I were to type that in, so let me fix something here. Sorry. Instead of a sub 30, because that's what I did.
It's 42,500.
I get, when I type that in, I get
42,500.
yes, fish.
Yeah.
Woo woo.
Good, good, good. After 30 years, he's only making 42,000.
He broke.
Broke. All right, so total money. So total, what does total mean I'm going to end up doing?
Adding.
Add.
Yes, so we're going to use that formula, the SN formula up there. So it's going to be after 30 years. So it's n divided by 2. So the n is 30 because that's how many years we want to figure it out. My starting term A sum 1 was 28,000. And then I'm going to add the 42,500. I'm going to go type that in, and guess what? I already have the answer. So after 30 years, he's only made a total of $1,057,000.
Hey, he's a millionaire.
But
After 30 years.
so barely get $1 million. This is a sad, sad story that's real.
For teachers. Yes.
For teachers.
Why did we go in this profession? Because we love
I
y'all.
know.
It's not about the money.
Yes. It's not about the money. It's about you. All right. Now there's another notation, this little sigma E, it looks like an E kind of, a Greek letter. They have this formula right here. So first I'm gonna, define what things are. Now they have this letter K because they can't keep using N. So what K stands for, it's the first natural number they want you to use. Sometimes it's 1, sometimes it's not. It's the first natural number. Then N is the last, so how many they want. So like if I were to do the previous problem, I would have 1 at the bottom and 30 at the top because that's what the last natural number they wanted us to use. I'm right, sorry, last natural number. And then AK, that is just my rule. So the explicit rule. Okay, that's what everything stands for in Sigma. So we're going to do example 3. I guess we're going to jump straight into the calculator, which is cool. So now I'm going to start with the newer calculator. So if you have this old guy, the TI-83, you got to wait because it's not even close to the same. All right, so if you have the new calculator, your life's going to be real easy. So what you're going to do is you're just going to get math. And then you're going to go, if you scroll, I scroll up because that's the fastest way to get there. You can scroll down until you reach 0. We want 0, and look, it even says solution with that little E. So I'm going to hit that. And then you just type it in. So they're using K. I'm just going to use X equals 5. And at the top, I'm going to top 21. And then you're going to use your rule. Now, so I'm going to replace this with an X. Since I use X, this is now X in my calculator. So I do 2X plus 4. Bam. So the answer is 510. So if I were to write out from 5 until the 21st term, add them all up, I would get 510. Okay. So how did I do that? So this is the newer calc. How did I get there? All I had to do was hit math. And then I had to scroll down to get the 0 summation.
And that's all we have to do?
Yeah, it's
so much faster than the other way, like all the ways.
Yes. Now, though, if you have this bad boy, it's a lot. So, and I'll write out the steps in a second, but let's just do it first. Maybe I should, no, yeah, let's do it. So I'm going to write it as I go. So I hit second list. So this is old calc. So I hit second list, which was stat. Second stat. And I'm going to scroll first over to math. So then scroll to math. And I'm going to hit the 1-5. Sum. So I'm going to hit 5 math and then hit number 5 sum. It's really hard to write these directions here. No. Hit number 5. Now, unfortunately, that's not all we have to do. So we go back to second stat. This time we go to ops and we got to hit sequence number 5. Okay. So then we have to go back to second list. Whoa. And then we hit over to scroll to ops and hit number 5 again, which is sequence. And oh my gosh. And then we have to type in everything. So the first thing we type in is the expression. So the expression is 2x plus 4. So 2x plus 4. And then we have to hit comma. And then we have to say what variable are we using, which is x. Then we have to hit comma. It's the first natural number, which they said is 5.
You have too many commas. You have too many commas.
Sorry. And then the last natural number, which is 21. And now I can hit enter and I get the same.
Doing too
So again, when you type that in, get a new calculator.
Yes. Or do it by
So it's the
hand.
expression, variables, and then your starting number, and then your last number. Sorry, running out of space. I guess I could have zoomed out. So expression, variable, start, last. Ugh, this is an ugly handwriting. I'm sorry, guys. But you get 510. Okay, easy, right? Yeah, I'm not using that calculator anymore.
Let's do the faster calculator from now on.
This is the last one. Last one. I'm sorry. All right, so they've given us, now this is another way they can write sums. So they say dot, 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 add to 46. Expressing summation. So the last natural number is not 46, honestly, because they've plugged into our formula, but we don't have anything. We got to figure out, so we're going to make our sigma. So the first thing we have to figure out is the expression. So first off, what kind of sum or sequence is this? So what am I doing each time?
You're adding 5.
Since I'm adding, it's an arithmetic sequence, so I can use the formula Fish gave us at the beginning. We're going to learn about a different sequence next class. You're not always adding, and it's called something else. So the starting term, so I'm going to make my explicit formula. The starting term is 1 plus my common difference, which is 5, and then I put n minus 1. Okay, and I'm going to clean that up. So 1 plus 5n minus 5, and then I get 5n minus 4. So this, and I'm going to use x. I know I used n's because I got to type x in my calculator. So 5x minus 4. So, and then the starting natural number we always plug in, make our lives easier, is 1.
Could I just do 1 plus 5
usually plug in anything else because then that changes. Yeah. Yeah, you can.
Just like you were saying earlier, like I don't have to.
So you didn't have to do that.
Gotcha.
Exactly, yes. But cleaning it up is going to help us figure out this top part. It is not 46. I cannot express that enough. That is probably one of the biggest mistakes I always see is that they put 46. 46 is not the last number I plug in. I had to plug in something into this formula to equal 46. So if I add over 4, that's 50. So really the last number they plugged in was 10, not 46. Because if I plugged in 46, that would be a really big number. You want to be able to plug in all your n's to get this. So there was really only 10 terms here in between. These dot, dot, dots, if we were to expand it all out, we would only see a line of 10 numbers. So we're going to use our calculator. So I'm going to turn it back on.
Do we
I'm gonna
have
go to
to
math.
sum? It just says express in summation notation.
Oh, it does. Oh, JK, I guess we're done. I'm doing too much.
Woo!
That's my answer. But if you found some, you would go there in your calculator. And if you have the old calculator, you know, you got to do too much. But yeah, that's it. All right, I'm going to stop sharing.
Woo.
And yeah.
Y'all made it.
Woo!
That was a long video, but we made it through, y'all. We made it through.
So we'll see you in class soon.
See you next time.
Yes.
Peace.